So in this brief example, let's talk about matching these actual correlation coefficients R to their actual scatter plots. And remember, the correlation itself is a measure of how straight of a line something is. The line can be either negative or positive, or it can actually have a zero slope. So when we look at these, the easiest thing we're going to be able to do is determine the actual slope of the graph first. So we're going to determine which graphs are negative and which ones are positive. And if you look at this first graph here is going to be a negative graph. And then the next graph looks like the first graph actually is a positive graph, because this is positive. If you look at the slope, you try to draw a line through there like you would a line of best fit. So you're trying to draw a line of best fit through all these. This is negative. This is positive. Negative. This is somewhat positive. And this last one is very hard to tell. So we don't really know, so we'll leave it like it is. We're not trying to draw a line through that one. So when I look at the first one, I know it has to be a positive graph. And you base these off of your coefficients that you have available to us. So we have your positive values are 0.5, 0.9, and 0.99. Well, realize that 0.99 is going to be the strongest, as close to a line. It looks like it's going to be C here. So our R here is just 0.99 because it's the closest to a line. The next closest to a line is A, and that'll be R equal 0.90. And then the one that's furthest from the line that's positive is E, and this R is equal to 0.50. So even without knowing what the actual values are, looking at this, looking at how close of a line it is, that's what I'm looking at for this. The closer it is to the line, the closer it is to either 1 if it's positive or -1 if it's negative. So same results going back the other way. The two negatives are negative 0.85 and negative 0.40. Negative 0.85 is a lot stronger, and that's going to be this right here. And then the other one, B, will be R equals negative 0.40. And then this last one is the one that's really hard to tell. And because it's so hard to tell if it's positive or negative to begin with, we're going to call this one R equals 0. So again, when we're looking at this, in this particular example, we're looking to see first the direction of the slope. If it's positive, negative, or if we can't tell the direction, is 0. And then we want to see how close of a line it is, because that's what correlation is, measuring the linearity or the linear strength and direction of a particular scatter plot.